test for analyzing 3 or more independent samples in Python using Jupyter Notebook, also known as the analysis of variance. But before we proceed, I'll urge you to kindly take a look at my previous tutorial video on the flowchart for classifying data, because in that video tutorial I have illustrated and explained the data structure for 3 or more independent samples, which will help you to catch up with everything that I'm going to do in today's tutorial video. Okay, so you can just click on the link in the card above or check the description of this video for the link. Okay. Alright, so one thing with regards to ANOVA is that it is one of the most flexible and practical techniques for comparing several means. And it is important to note that ANOVA is not about analyzing the population variance. However, the basic concept of ANOVA is to test for the differences among the means of 3 or more independent samples by examining the amount of variation within each of these samples relative to the amount of variation between the samples. The types of ANOVA include one-way ANOVA or completely randomized design, CRD. We also have the two-way ANOVA with no interaction effect, also known as the randomized block design, RBD. And we have the two-way ANOVA with interaction effect, also known as the two-way factorial design. Okay. But in today's tutorial, we are just going to cover the CRD, the RBD, and the two-way factorial design will be covered in our subsequent tutorials. Okay. Alright, so like the two independent samples, we have parametric tests and non-parametric tests for analyzing such data. The same applies with having 3 or more independent samples. So the type of parametric test for analyzing 3 or more independent samples is known as the one-way ANOVA. This one-way ANOVA model compares the means of 3 or more groups or samples to determine whether there's a statistical evidence that the associated population means are significantly different. Okay. So for example, researchers might want to compare the mean income level of 3 regions, or researchers might want to compare the mean nitrogen content of 4 lakes, or researchers might also want to compare the mean effectiveness of 5 drugs. There are certain assumptions which must be satisfied before this test can be used. One of the assumptions is that the groups or samples are independent. Another assumption is that the response variable is continuous, and also the data follow the normal probability distribution. And the last part of the list is that the variances of the samples are equal. Okay. So now let's take a look at the non-parametric test for 3 or more independent samples. This is known as the Kruskal-Wallis test. This test compares the medians of 3 or more groups to determine whether there's a statistical evidence that the associated population medians are significantly different. Okay. So for example, researchers might want to compare the median income level of 3 regions, or the median nitrogen content of 4 lakes, or the median effectiveness of 5 drugs. Okay. So there are certain assumptions which must also be satisfied before this test can also be used. One of the assumptions or conditions is that the groups or samples are independent, the response variable is continuous, the data does not follow the normal probability distribution, all groups have identical shape distributions. Okay. So now let's take an example. A betting company has introduced a new gaming policy in 4 countries, namely A, B, C, and D. The betting company randomly selected 5 areas in each country and recorded a daily income in dollars at each selected area. The dataset is shown in the attached bet dataset. The betting company wishes to determine if there is any significant difference in the average income among the countries. We want to conduct a detailed statistical analysis for this problem in Python using Jupyter Notebook. Alright, so before we jump into our Jupyter Notebook, let's take a look at the bet dataset in a CSV format. So here we go. We have 3 variables: country, area, and income. Okay. Now our objective here is to determine how this income vary among the countries. So this is the income for country A. I'm going to highlight that. So we have 5 of them, and we also have the income for country B, and this is the income for country C. Okay. And this is the income for country D. Okay, that's for D. So we want to find out how this income vary among the countries. Okay, but there is another variable that can also influence our response variable, which is area. Okay, so this variable is served as a nuisance variable, or a concomitant, or sometimes also referred to as a confounding variable. These are variables that can influence your response, but they are not of primary interest in your research study. Okay, and you want to control this variable. Okay, because if there is a betting company in an area where most of you don't have interest in betting, definitely the income level will be different compared to an area where most of the youth have interest in betting. Okay, so we would like to control the source of variability that may come from here. So if a nuisance variable is known and it can be controlled, then we use the blocking principle. Okay, so where blocking is basically the process of grouping similar experimental units together into blocks in such a way that the units within each block are more or less homogeneous. Okay, but if the nuisance variable is known and it cannot be controlled, then basically you are going to apply the analysis of covariance. Okay, but that will be covered in our subsequent tutorials. So in these tutorials, we are just going to cover that of the completely randomized design, as a CRD. Okay, so we just want to find out how income vary among the countries. So now let's quickly jump into our Jupyter notebook. All right. So the first thing that we want to do is to import our data set. But before that, we need a library for our data importation and other data analysis, which is the pandas library. So we want to import pandas as PD. Let's run this. All right, let me scroll down. Alright, so we now want to load our data set. So I'm assigning my data set to bet, and for the pandas slide, I'm using the function read underscore CSV. I have this data file in my folder where I have the Python source file, so there's no need for me to create what do we call it, a different working directory. So I have my data file here. I'm going to leave this data file in the description of this video so that you can download it, and it is in the same folder where I have my Python source file, so it makes the computation easier. Okay, so make sure that you have this data file in the same folder where you have your Python source file. So let's go back to our Jupyter notebook. So I think it's still loading. Once it's done, we can load our data set. So let me try and run this. Control enter. So it's still compiling. Once it's done, we can then proceed to view our data set. Okay. Alright, so I think we can now view our data set. Control enter. So this will display the data set in a spreadsheet form, like what we saw in the spreadsheet form, right? What we saw in the CSV format, right, in the Excel. Alright, so I think we are good to go. Now let's take a look at the structure of our data set. So control enter. Alright, so we can see here that we have 20 entries indexed from 0 to 19, and we have 3 columns which include a country, area, and income, and you can see the data type for country and area are object, right, and that of income is float64, which is numeric. So in our data manipulation, we are supposed to encode this variable by converting it into a factor or a categorical type as country and area. Okay, so let's quickly do that. So I want to recode country and area into factors. So we are going to use this code of line to do that. So let's run this. Control enter. Alright, so now let's look at the structure now of our data set. Control enter. Alright, so we can see that now country and area has become converted into a categorical type, so we are good to go. Alright, so the next thing that I want to do is now tackle the main issue. We want to determine if there is any significant difference in the average income among the countries. Okay, so the first thing that I want to do is to basically get some numerical summary of the income for each country. Okay, we have to get some idea of how the average income vary among the country before we start with our main analysis. So let's quickly run this to get the results. Control enter. Alright, so here we go. So we can see the mean. We have some numerical summaries here, but we are just interested in the mean. Okay, we have the standard deviation, the minimum, the maximum, the quantiles also here. Now let's look at the mean for country A, which is 17.33. That of country B is 15.92. Right, country C is 20.71, and that of country D is 25.42. Okay, we want to find out how this average income vary among the countries. So we want to find out if the difference in this average income is significantly different from 0 or is equal to 0. Now if you look at that of country A average income and that of country D average income, you can see that if you take the difference, is going to be very wide. So we want to find out if that difference will be will be significant difference from zero or it will be close to zero. Okay, we want to do that simultaneously for all these countries. Now we can also visualize our income distribution by using some box plots. So we want to import the Seaborn as SB. So from the Seaborn library, we are making sort of function box plots. So on the x-axis, we want to have our country, and the y-axis, we want to have our income, okay? And the data is bet data. So let's run this to see the result. Control Enter. It's still compiling. So now we can see the results. So for country A, you can see that the income has, we have some extreme value here, which seems to be an outlier. For country B, the distribution of the income seems to be nearly symmetric. The same applies to that of country C. For country D, also the distribution seems to be a little bit symmetric, but you can see that the area on the lower half of the median seems to be greater than the area on the upper half of the median. Okay, so I think with this we have an idea of how the variation of the income vary among the countries. Okay. Alright, so the next thing that we're going to do is to fit the ANOVA model. We want to fit this model so that at least we can test for the assumption. Okay, we are going to make use of the residuals, which is the difference between the actual values and the estimated or predicted values. Okay, so we want to import our stat models .api as SM. We need this stat models API because we are dealing with a cross-sectional data, so it's very appropriate for cross-sectional data, and our data set is an example of cross-sectional data. Okay, so from the stat models API, formula.api, I want to import the OLS, that's the ordinary least squares. So we want to fit our ANOVA model and want to make use of the OLS function. So income is being described by country, and our data is the bed data. So we want to fit this. Let's quickly run this. Control Enter. So once it's done, we can then make use of the residuals from this fitted model to test for the assumptions. Okay. Now with regards to assumption, the first one we can see that if you look at, let's go back to our CSV format, you can see that the countries are basically independent because these are different groups. Country A is different from country B, country B is different from country C. The same applies to country D. Okay, so the observation that you're going to have for this particular country for this has no influence over this one. Okay, so for country B, so because the groups are different, basically they are going to be independent. Okay, and you can also see that the response is continuous because this is a continuous data. Okay, so the next assumption that basically we want to test is the normality assumption. Okay, we want to start with a QQ plot. So we want to get a normality test using QQ plot. So we want to import the CPy stat as SS and also import our pilot. So once we run this, so from the CPy, I'm assigning my plot to QP. So from the CPy stat, I'm making use of the probability plot function. So from the fitted ANOVA model, I'm making use of the residuals, and I want to find out if this residuals is closely or is approximately normal. So let's quickly run this to see the results. Control Enter. Alright, so when you scroll down, you can see that most of the points are on the straight line sloping upwards to the right, which is an indication that the distribution of the income across the countries is normally distributed. Okay. The other test for normality that we can also rely on, like the Shapiro-Wilk test. So here I want to make use of the Shapiro-Wilk test. So from the CPy stat, I want to import a function Shapiro. So let's run this, and I'm going to make use of the residuals from the fitted model. So let's run this to see the effects. So we are interested in the p-value. We want to compare this p-value to the alpha level at 5%. And we are going to reject the null hypothesis if this p-value is less than or equal to the alpha level at 5%. Okay. Now, because this p-value is greater than the alpha level at 5%, it means that we are failing to reject the null hypothesis and conclude that there is enough evidence to indicate that the distribution of income, right, among the countries is normally distributed. We can also make use of the Anderson-Darling test, right? So from the CPI start, we want to import Anderson. So I want to also check for the normality using Anderson-Darling test. Let's run this to see the result. Control Enter. So in here, we are going to make use of the test statistic and compare that to the critical value. Okay. So the critical value at 5% is 0.692, and in making a decision with regards to the test statistic and the critical value, we only reject the null hypothesis if the test statistic is greater than the critical value. Okay. Now, because the test statistic value is less than the critical value at 5%, we fail to reject the null hypothesis and conclude that the distribution of income across the countries is normally distributed. Okay. All right. So the next assumption that I want to check is the test for homogeneity and variance. Okay, we want to find out if the variation of income among the countries are the same. But before we do that, I want to filter income for each country. So here I want to filter income for country A, I want to filter the income for country B, I want to filter income for country C and for country D. Okay, this is basically what we are trying to do. We want to pick the income base for country A. So we are just picking that for country A. Then also filter income for country B, also filter income for country C, and also get out income for country D. So that's basically what we're trying to do. Okay. Alright, so once we are done with this, we are going to make use of the pathless test. This test is quite often used to test for homogeneity or variance for 3 or more independent samples. Okay. Some people may also rely on the leveling test. Okay, but the appropriate test is the pathless test. So from the CPI start, we are making use of the pathless function. So let's run this to see the result. Control Enter. Oh, sorry, I didn't run this. Let's first of all run this. Control Enter. Okay, so now we can run this. Control Enter. Alright, so there's a p-value. You want to compare this p-value to the alpha level at 5%. Because this p-value is greater than the alpha level at 5%, it means that we are failing to reject the null hypothesis and conclude that there's enough evidence to indicate that the variation of income among the countries are the same. Okay. Alright, so now that we are clear that all the assumptions has been satisfied, it means that we are going to make the parametric test, which is the OneWay ANOVA. Okay. So our test of hypothesis, our null hypothesis, we can state it as there is no difference in the mean income among the countries, and alternative can also be stated as the mean income differs for at least one country. Okay, so let's get to the summary of our result. So I want to get a summary of our ANOVA model. So from the start models, right, we want to basically employ the ANOVA linear model to our fitted model to get our result. So let's run this to see the result. Control Enter. So when you scroll down, you can see this the country, and want to find out if this country differs. Right now, you can see that the p-value here compared to the alpha level at 5% indicate that we are going to reject the null hypothesis and conclude that there is enough evidence to indicate that the mean income differs for at least one country. So the next question is, which of these countries differs? How do we determine the country that differs in terms of the average income? How do we get that? So we're going to employ the multiple comparison test. So in here, we want to import the start models, start the multiple comparison function as MC. This will help us to determine which of the countries differs. Okay. And specifically, we are going to make use of the function which is the 2K HSD test with the 2K honestly significant difference test. This function, or let's say the 2K HSD test, is basically good for making pairwise comparison between means when the groups have the same sample size. So when you have groups, or when the sample size differs among the groups, then basically what you're going to do is to try other tests like the 2K Kramer test or the Duncan's test. Okay, because here the sample size are the same for all the groups, we want to make the 2K HSD test to get our work done. So let's run this code offline to see the result. Control, sorry, run. Alright, so in here we can see that the difference, so this is the groups, group A, group B, country A, country B, and this is the mean difference, and from the p-value, right, we are basically going to it's false, right? So compare this p-value to the alpha level at 5%, it means that we are failing to reject another hypothesis. So there's the difference um, is close to zero. Okay, it is not too different from zero. Now let's look at where the difference lies. If you look at country A and country D, the mean difference is 8.09, and if you compare this to zero from the p-value, it means that we are basically going to reject another hypothesis. So yeah, the decision that we are going to reject. Okay, so it's true. Okay, because this is less than the alpha level at 5%. Okay, the same applies to country B and country D. If you look at the p-value 0.0053 compared to the alpha level at 5%, means that we are going to reject another hypothesis, right, and conclude that the mean income difference between these two countries, country B and country D, if you look at the mean difference 9.5, which is totally far from zero. But if you look at 4.79, that's between country B and country C, the mean difference is 4.792, and this is not different from zero. Okay, so the decision here is that is false. Okay, that is we are failing to reject it. All right. So now let's assume that the normality test failed. Then it means that we are going to employ the Kruskal-Wallis test. Okay. So in here, the null hypothesis is going to be like there is no difference in the median income among the countries. An alternative will be the median income differs for at least one country. Okay. So for Kruskal-Wallis test, let me scroll down. You can get that by making use of this the cpy-stat function or the library. From the cpy-stat library, you are going to employ the function Kruskal to get a result for the Kruskal-Wallis test. Okay, and we have already filtered this. This is the income for country A, income for country B, income for country C, and income for country D. So let's run this. Run. I'm used to control enter. So alright, so we want to compare this p-value to the alpha level at 5%. It means that we are going to reject the null hypothesis and conclude that the median income differs for at least one country. So the question is which of these country differs. We can also get that multiple comparison test from the Kruskal-Wallis test by making use of the a library known as the scikit post-hoc. So you have to first of all install this. If you have not installed, if you don't have this installed, then you have to install. But if you already installed this library, then you can skip this and just comment on that. So I'm going to skip that. I'm just going to load it. So I want to import a scikit post-hoc as SP. Okay, so control enter. Alright, so now I want to create a data frame. To get our work done, I want to create a data frame. Right, so I want to put A, B, C, D in a data frame. Then from the cpy post-hoc, I want to make sure the downcast test to get our work done, and the P adjustment we are making sure the Bonferroni. Right, so let's try and run this to see the result. Control enter. Alright, so the 1 stands for country A, 2 stands for country B, 3 is for country C, and 4 is for country D. So you can see here that the difference basically lies between country A and country D, which is country A and country D. This is where the difference actually lies, okay? And here we are not looking at the mean, but of the median. So when you are making the pairwise comparison for the median, it means that the difference lies between only these two countries. That's for country A and country D. Okay, the remaining are all insignificant. Oh, I think we have another one here. Between country um, B and country D. Okay, here we have 0.045 compared to about 5%, means that we're also going to reject an hypothesis and conclude that the median income vary among these two countries. Okay. All right. So I think we are now good to go. So this is basically how to conduct a detailed statistical analysis for 3 or more independent samples in Python using Jupyter Notebook. Right. Alright, so please, if you find value in today's tutorial video, don't forget to subscribe if you have not, and also turn on your notification bell to get more updates anytime